In this segment, we'll talk to you about refracting telescopes. These are telescopes that gather light through convex glass, bringing it to focus down here at the eyepiece. Now, a refracting telescope is typically what most people visualize when you say the word telescope. The traditional long tube, the eyepiece here at the back, is very simple and easy to use and typically pretty low maintenance. Refracting style scopes are ideal for lunar and planetary observing, and at different price points can offer obviously different quality of the picture that you see. One of the advantages of a refractor is that they're relatively inexpensive from a beginner's point of view, and if you're going to do terrestrial daytime viewing, you must have a refractor. Also for light polluted areas like if you're in the middle of the city, you want to gather some light, but as you gather more light, you gather light pollution as well. So inside the city, someone is viewing off a balcony or something like that, I will recommend usually a 80mm refractor, and realistically from there you will do lunar, you'll do planetary, you can do some double stars. But basically where the refractors lack is just light gathering ability. If you want to see the more distant objects, if you want to get outside the Milky Way galaxy, you really need to step up to a little bit more of a light bucket. I say refractors are relatively inexpensive to get started with, but it also depends on the type of glass you're going to get into. Typically there are three types of refractors. There's what they call an achromat, and there's an ED glass and an apochromatic. Now with an achromat, they're referring to how the colors, how the light path comes into focus to your eye. The red, green, and the blue light spectrum travel at different lengths. So in an achromatic telescope, all those colors don't quite hit your eye at the same point. That means as you're trying to push the magnification a bit, you're going to get what they call false color, or chromatic aberration, meaning a bright object like the moon at 100 magnification might give you a little green or yellow or even purple hue to it that can be distracting for people that want to view planetary at higher powers. If you step up to what they call an ED lens, an extra low light dispersion lens, that corrects that color a bit more for you so you can get higher magnification. Also, the contrast gets a little darker too, so that bright object stands out a little bit more. Refracting telescopes that boast that they are apochromatic are truly the most premium instruments on the planet, and they'll command a premium price as well. A guy like this right here will push the Dawes limits. When I said you can get 50x magnification per inch of aperture right here, this little 4-inch scope, because of its quality, because of the glass, because of the design, can actually push 150, 200, 250 magnification without any false color. They have taken the time to make sure that the red, the blue, and the green hit your eye at the same time. So an apochromatic scope will give you no false color as you increase the magnification. There are exceptions, of course, but if you're looking at refractors, you should understand the term achromat, ED, and apochromatic. This will help you in choosing a refracting telescope. Again, the apos, the most premium instruments, the darkest contrast makes those dim fuzzies pop out a little bit better. As premium of an instrument as they are, they still lack a little bit of aperture. We're going to talk about larger Newtonian telescopes here coming up.